Now, in this video, I want us to take this opportunity and try and understand how we can use another theory to define existence of matter in different states. And the theory I'm talking about here, or the theory I'm going to talk about, is known as the kinetic theory of matter. The kinetic theory of matter. And this is a wonderful theory in explanation of the existence of matter in different states, which I would expect you to know and understand. Now, to explain this theory, I'm going to start by posing a question to you. If you look at the globe or certain drawings of the whole Earth, you'll come to realize that, or for those students who are doing geography, you'll come to realize that on the globe we have the northern hemisphere and the southern hemisphere, majorly around the Arctic region or the polar regions. In those regions, we have several ice cover almost throughout the year. But in certain regions, as you are moving to the Capricorns, the tropics, you come to realize that within the tropics, certain regions can have ice cover in certain seasons of the year, but not all. But when now you come to the equator, you realize that, especially Africa, sometimes we literally, in fact, I've never seen ice cover around the equator, especially in Africa. This behavior of ice cover demonstrates something. I don't know whether you're understanding it. The fact that we have rain demonstrates something. So I would want you as a student of chemistry to always be curious of everything you see in nature. If you see wind blowing, why is it blowing? Ask yourself the differences in pressure. If you see anything you see in nature, there is a reason as to why something is behaving that way. And there is always scientific study that justifies that behavior. So as we are going to look at the kinetic theory of matter, remember I've said matter exists in different states: solid, liquid, and gas. And these are things we have in nature. So for example, if I have a ball, I'm going to sketch a ball of ice. I'm going to pretend that this is my ball of ice. And I'm going to have a container containing liquid water. And after that, I'm going to have the same container being heated, and that water is evaporating. And I want to try to explain this. When I have my ice, when you heat it, it gives you liquid water. When liquid water is heated, you get vapor. Then the reverse of this happens when all these things are cooled. This is the principle that we have that led to the introduction of fridges that we use at home and dispensers. Now, ice is a solid. Water is a liquid, and in this form I'm having vapor, which is a gas. You'll realize that there is change of states. What is very key about these changes of states is that heat is involved. Heat is involved. And what is so funny about them is that particles within matter absorbs heat energy. When particles absorbs heat energy, their kinetic energy increases. And it is this increase in kinetic energy that makes particles to move about. Now, in explaining existence of matter in different states using kinetic theory, we are going to talk about movement as far as particles within matter is concerned. Now, I'm going to do another sketch. So I'm going to have my solid. I'm going to have my liquid. And lastly, I'll have my gas. And all of them, I want to use simple terms to explain them. In our previous video, I did a drawing that resembled this to demonstrate particular theory of matter. In the liquid states, I did something that looks like this. In the gaseous state, I did one that looked like this to show that they are far apart. They're generally far apart from each other compared to the liquids. Yes. Now, I want to use particulate theory, no, not really, kinetic theory to explain what is happening in each and every state. Now, in the solid state, matter consists of particles. That's the first key thing. And these particles are closely packed. And if they are closely packed, these particles have less kinetic energy. And in case they absorb heat energy, they will vibrate at fixed positions. What is causing that is they have strong forces of attraction between them. The particles in solid states have strong forces of attraction. That's why they can only vibrate. However much their kinetic energy increases, but they will only vibrate at fixed positions. Now, in liquid state, matter consists of particles. These particles are generally close to each other. They are generally close to each other, and they have more kinetic energy. than solid particles. They have more kinetic energy than solid particles. So if that, what is happening? So what will happen when they absorb heat energy from the surrounding? They'll move about, but their movement is restricted to be within the liquid. And for that matter, as a good students of chemistry, you should be able to explain that this is why liquids take the shape of the container. That should be placed as an NB for you not to forget. Liquids tend to take the shape of the container, because the movement of particles within that liquid is only restricted within the liquid. It cannot go past that liquid. Now, if we go to the gaseous state, it still consists of particles, and these particles are far away from each other. They have excess energy, and this excess energy makes them to move randomly in all directions. They move randomly in all directions, and that is why you can't see gases, because the particles are far apart. For those who are handling physics, you know the Brownian motion. Yeah, the particles cannot be defined. You can't define the direction they'll take. They can move randomly in any given direction. So that's the explanation of the of the kinetic theory of matter that can be used to explain the existence of matter in different states. Thank you very much and have a wonderful time.